All right, first up, number 2 here. So we want to state the degree. Now, whenever we don't have any exponents, that is always degree, or any variables, I should say, that's degree 0. Because it's really kind of the 0 power. And then my leading coefficient then would be 10. It's really the only number there. And then this is obviously a monomial since there's only one term. Number 4 is actually degree 1. Because that's actually the first power. So that's kind of the difference between 2 and 4 is if you have a variable with no exponent, it's first power, but no variable is 0 power. And then my leading coefficient would be 2. And then this is another monomial. All right, next up, number 6. So on these ones, first of all, we multiply the outsides and leave that outside. And then inside, I just actually always leave these separate. And then we can leave these separate as well if you like. So then I really break these down like that. And then I can break down these as well. And we're looking for twins here. So the twin 3's, I got twin p's and twin p's again. So they all get to go outside. But remember, we already had that negative 10 outside, so that's going to stay there. We're going to bring the 3 out. And then we're going to bring p and then another p out. And then inside the radical, we'll put the loners. So we had a loner 2 and a loner p, so that'll be 2p. And we'll just simplify this to negative 30p squared times the square root of 2p. All right, next up here, we want to rationalize the denominator, but I actually want to reduce it first. So we can always reduce inside the radical with inside or outside with outside. The key is you can't simplify inside the radical with outside the radical. So I'm going to divide those both by 4. So this becomes 3 rad 2 over 2 rad 3. And then we can we always multiply by the radical in the denominator, so that'll be rad 3 here. So that multiplies inside times inside, so that'll be 3 rad 6 on top. The outside, it's kind of multiplying by 1 if you want to think of it like that. So on the bottom we have 2 times the square root of 9. Now whenever this happens, the square you should have a clean square root on bottom, so I'm going to turn that into a regular 3. And so then we get 3 rad 6 over 6, and then we can actually reduce outside with outside, dividing by 2. And so that's going to give me, or not by 2, excuse me. It is by 3. And that's going to make a 2 on bottom. That's what I was thinking of. And then up top, it'll be 1 rad 6, but I'm just going to write that as radical 6. All right, next up, number 10. So for this one, we got to send in this exponent since we got it outside the parentheses. It goes to everybody inside the parentheses. I do have some invisible exponents, so I want to put a 1 there. So then it becomes 2 to the 3rd. This will multiply by all the exponents. X to the 0, y to the negative 12th, and then y to the 3rd. So I multiplied all those by 3, everything in the parentheses. Next up, I would actually move negative exponents. So I got 2 to the 3rd on top. I got x to the 9th is going to stay put. Y to the negative 6th, I'm going to move to the bottom. X to the 0, I'm actually going to cross that off. It's really 1, but since it's multiplying other stuff, it's irrelevant. So then I have y squared on top and then y to the 3rd on bottom. Next thing I can do is I can actually combine these and make that y to the 9th. And then I'm going to battle out these y's here. So I see that the top has more, so they're going to win the battle. So then we're going to have a y on top, and we subtract the exponents to figure out what's there, which is a 3. 2 to the 3rd power, 2 times 2 times 2, I know is 8. And then x to the 9th, and then that's our answer. The denominator is really 1 here, but when we have a denominator of 1, we just don't put it. This one I need to distribute first, so I get 8n squared minus 3n to the 3rd. I'm just adding the exponents there, and the first one, since it didn't really have an exponent, I just attach it to the 8. Here, same idea, I need to send that in, so 2n to the 2nd if we add those exponents, and then 7n to the 3rd, and then minus 4n. And now we're just going to combine like terms. So I'll do it in order. I got negative 3n to the 3rd, and 7 and a third. And by the order, I mean order of powers here. So I combine those two. I just add the numbers out front. But now that I'm adding, the exponent will not change. When we're multiplying, it does, but when we're adding, it does not. We just add the numbers out front. Then I have my n squared. So I have 8n squared and positive 2n squared. So that's going to make 10n squared. And then finally, that minus 4n out back doesn't have anybody to combine with, so I just keep it there. So that's our answer. All right, next up, number 18. So this one I'm going to send it in. So that's just going to be 1 times x squared, which is just x squared. This one it's going to add to the exponent, so it'll be 2x to the third. And then this one I need to send in as a negative x squared. So that's going to be negative 5x squared. That's going to be negative 4x to the third if I add those exponents. And then minus 3x to the fourth if I add those exponents. So now I'm going to combine like terms. Looks like negative 3x to the fourth has nothing to combine with, so that's fine. Next up, I'll add my 2x to the third, and negative 4x to the third is going to make negative 2x to the third. And then finally, my x squareds, I have positive 1 and negative 5, so that makes negative 4x squared. Once again, when we're adding on that step, our exponents do not change. All right, next up, we're going to solve these equations. And so I would always distribute and combine like terms first on each side. So this will be a negative 6, and that'll be plus 21n. So it's a negative times a negative. And then this one will be plus 3, and this will be minus 24n. And then I'm just going to combine like terms there. So these ones will combine to negative 3n, and these ones will combine to negative 3. And then I'm going to do the same thing on the right side of the equation. So I'm going to combine the positive 1n and a negative 5n. So that's going to make negative 4n. And then I have negative 2 and positive 5 make plus 3. All right, so next step, I always want to get the variables over to one side. So I'm going to add the 3n to each side. You could have added 4n as well. It really doesn't matter. I kind of like to move the smaller one. So then that'll be negative 3 equals, and this will actually be negative 1n, or just negative n, plus 3. Next step is to subtract this 3 over here, so then negative n equals negative 6. And then we'll just divide by negative 1 to get rid of the negative, so n equals 6. And that's it. All right, next up here, same idea. So I'm going to distribute this negative 3, so it'll be negative 3p plus 18. And then distribute this negative 3 as well, so it's actually a positive 18 minus 9p minus 7p. Now I'm going to combine like terms over here, so that's going to make negative 16p, because they're both negative. They actually add together to make a bigger negative. And now I'm going to move the variables over to one side, so I'm going to add 3p over to this side. So that'll give me 18 equals negative 13p plus 18. Now we're going to subtract 18 from each side, so we get the numbers to the other side, variables on one side, numbers on the other. And that gives you negative 13p. Now we're going to divide by negative 13 to isolate p. 0 divided by anything is always 0, so that's just our answer. All right, next up here, same idea again. We're going to distribute into here, so we get 2x minus 2. And then this one we need to distribute a negative 2, so that's going to be negative 8x plus 16. And then I'll just combine those like terms. So I have negative 6x there with the positive 2 and the negative 8. And then minus 2 plus 16 is plus 14. And then I'll do the same thing on this side. I have a negative 3 and a positive 7 to combine, so those make 4. And then negative 6x is going to stay the same. So now I'm going to get the variables to one side by adding 6x. And then I see that everything cancels, or all my variables cancel out, and I'm left with 14 equals 4. Now, whenever your variables cancel out, it's very important that you see what's left over. If it's true, then it's infinitely many solutions. If it's false, like this one is, it is actually no solution. So obviously 14 does not equal 4. All right, next up here, we're going to solve these by elimination. So on this one, I could eliminate either the x's or the y's first. I'm going to go ahead and multiply this one by negative 2, which will eliminate the y's. If you wanted to eliminate the x's, I would have multiplied the other equation by positive 3. But this one is going to turn into negative 12x minus 4y equals positive 28 if we distribute that in there. And so I see that, as I was kind of saying, the 4y and the negative 4y will cancel out. These ones are going to give me negative 14x because I'm going to add these two equations together. and then 0 plus 28 equals 28. So now I'm going to divide by negative 14 to both sides, so I get x equals negative 2. And then we're going to go ahead and plug that back in to find y. I can plug it into any equation I want. I'm going to go ahead and plug it into the second one there, which was right here, was negative 2x plus 4y equals 0. Obviously that says it's x, so I'm going to plug that in for x. And so that would say that 4 plus 4y equals 0. So I'm going to subtract the 4, and I get 4y equals negative 4. I'm going to rewrite that over here, and then we'll divide both sides by 4, and y equals negative 1. I always like to list the answers here as the coordinate points. That would be negative 2, comma, negative 1.